Good day. The problem is about radiation. A furnace is in the form of a cube 0.3 meter on a side inside. The gas inside at 1.0 atmosphere total pressure and 1100 Kelvin contains 10 mole percent of carbon dioxide and the rest is oxygen and nitrogen. The small amount of water vapor present will be neglected. The walls of the furnace are maintained at 600 Kelvin by external cooling. The calculate the total heat transfer to the walls neglecting heat transfer by convection. If the interior walls are not black surfaces but gray surfaces with an emissivity of 0.75. So the required is to find the total heat, which is represented by Q total, and the given is a cube with a side of 0.3 meters and the temperature inside of the gas is 1100 Kelvin and the temperature of the wall is maintained at 600 Kelvin. So for the solution, we will be using the general equation Q over A is equals to Steph Stefan Boltzmann constant times the effective emissivity quantity emissivity of the gas multiplied by its temperature raised to 4 minus absorptivity of the gas times the temperature of the wall raised to 4. So to find the emissivity and the absorptivity of the gas, we first solve for the mean beam length. And since we are given of furnace to be a cube, we will be using L is equals to 0.60 times D, which is the side of the cube. Therefore, we will be having a 0.180 meters of mean beam length. And to find the gas emissivity, we will multiply the L with the partial pressure of the gas, and since inside the cube or the furnace, the overall gas or the total pressure is 1 atmosphere, and since the carbon dioxide inside is 10%, then 0.10 times 1 is 0.10 atmosphere. And the L is 0.180 meters. Therefore, we will be having 0.0180 atmosphere meter. And basing on the figure shown, since the temperature of the gas is 1100 and the PGL is 0.0180, therefore the the gas emissivity is around here, which is assumed to be 0.068. And to find the absorptivity of the gas, we will still use the figure, but we will multiply the PGL to T1 over Tg. T1 is 1100 T1 is 600 Kelvin and Tg is 1100 Kelvin. Therefore, we will have 0.0982 atmosphere times meters. And basing on the figure, at 1100 Kelvin and 0.0 0.00982 atmosphere times meter, it is around here. Therefore, it is assumed to be 0.05 for the absorptivity of the gas. But based on the rule, we still have to multiply the absorptivity that is obtained in the figure to temperature of the gas over temperature of the wall raised to 0.65. Therefore, we will have 0.0741 to be the absorptivity of the gas. And the constant is 5.676 times 10 raised to negative 8 watts per meter squared Kelvin raised to 4. And basing on the furnace, which is a cube, the area is 6s squared, which is 0.54 meters squared. And since the furnace is not considered to be a black body, therefore we will use the effective emissivity. For a non-black body object which has a emissivity of greater than 0.7, we will use this equation emissivity plus 1.0 all over 2. Since we are given of emissivity which is 0.75, then we will have the effective emissivity to be 0.875. And substituting all the values, we will come up with a total heat transfer of 2412.5239 watts or 2.413 kilowatts. Thank you.